Good morning, I guess. Welcome to the math tutorials. This is my first video on how we're gonna make matrices in Godot Engine. Like, if you know what is matrix and basics operation with it, you can skip to this part of this video. Or else, if you don't know, uh, let's learn together. Yeah, let's get into the video. Like, um, when it comes to the matrix, you can just represent the matrix by the square bracket. Like if you just want to make a simple 2 by 2 matrix where it has four elements like 1, 2, 3, and 4. Suppose if you just naming it as a, this is nothing but a 2 by 2 matrix which has two rows and two columns. That's pretty much it how you describe a matrix. This matrix is also known as square matrix where this where the row is same as column. We'll just look around with the matrix which has different rows and different columns. Um, when it comes to the matrices, you can just let me undo this. Yeah. When it comes to the matrices, you can just look like this. Like you can just make a vector and make it as a matrix. Like consider this is a vector. Consider B is a matrix which is multiplied with the x, y, and z. So consider B is a vector. We can just represent a vector by two matrices, which we, if we just multiply this, like 1 into this and 2 into this and 3 into this, which is nothing but the row into column. So you'll just get B is equal to, from this point we don't have to mention it as B, we can mention it as B bar is equal to uh, Ix plus 2y plus 3z, which is nothing but a point in a coordinate at in a coordinate axis, or you can just say it as like um, it's just a position vector of an object which is with respect to the origin. So you can also represent matrices like this. You can also represent vectors in the matrix. We can just assume that um, the vector with one column and three rows, it's a 3D three-dimensional vector, and a vector with two columns, sorry, a vector with two rows and one columns, which is known as two-dimensional vectors, and the vector with one column and three rows, which is known as three-dimensional vectors. That's pretty much it about the declaration of vector thing, and I'll just show you how we can make a custom matrix, like not the square one, with as many rows as we want and as many columns as we want. So consider this the same matrix P, which is 1, 2, and 3, 4, 5, and 6. So this matrix can be represented by the number of row it has and number of column it has, like which is 2 into 3. So the B as an order of 2 into 3. So that's pretty much it. That's how you describe a matrix. And if you just want to increase the rows and columns in it, you'll just put the rows 3. It just has 3 rows in the matrix like this. Just a second. Where is I have this simple element 3, 4, 5, 9, and which is nothing but a 3 by 3 matrix now. That's pretty much it. That's simple. Now let's get into the matrix addition. Consider this is an Ascending matrix where you add both matrices like this: 1, 2, 3, 4, 5, 6, and you just add another matrix with the same thing for the for the sake of simplicity. 4, 5, and 6. So if you just add this, if you just want to add these two matrices, so you just want to look the each element 1 and 2 and 3 and 4, 4 and 5, 5 and 6 and 6. So if you just calculate this, we'll just get a matrix of 2, 4, 6, sorry for that, 6, 8, 10, and 12. This this is a matrix. That's how you add a matrix. It same applies to the subtraction too. Like if you just add the if you just want to subtract two matrices, you have to follow the same procedure as we did in the addition, and you can just subtract each elements rather than adding that. So let's move into multiplication of a matrix. So if you just want to multiply two matrices, you have to look for the condition. Like if the if the column of the matrix A is equal to the row of the matrix which you're going to multiply, if it is not equal to that, you can't add and you can't multiply a matrix. That's the thing you have to keep in your mind. And so to keep the thing stable, so it is a 2 by 3 matrix. 2 by 3 matrix. So to keep the 3 in the row side, we have to create a matrix of 3 by 3 or 3 by 2 or 3 by 1. For the sake of simplicity, let's create a matrix of 3 by 1. So this is a matrix of 3 by 1. So to multiply the matrices, you have to multiply the row with the column, and you have to multiply this row with the column. So you can just get like 1 plus 2 plus 3 plus 4 plus 5 plus 6, which is nothing but 6 plus 15. Yeah, 6 plus 15. So we can just come to a conclusion that the multiplication of the matrix will be this, like the the resultant multiplication of the matrix will be in the order of 2 into 1. That's pretty much it, the basics. I hope you guys understood this. Or if you just have a query on this, you can just hit me up in the Discord. The link will be provided below after this video. You can just check that out, and let's get into the code. Yeah, we got into the code. So this is a base scene where a matrix is a node 2D which has a script attached to it. So if you just look into the script, it just extends from node 2D and has a class name of matrix. So it has a selection vector. I'll just explain about it real soon. So first it initializes the values of the matrix. For example, if you just want to initialize the 3 by 3 matrix as I told in the video, like var matrix is equal to initialize total matrix of the value. It's gonna have 3 rows and 3 columns, and the value is gonna be I just want to set a value total value of the matrix as 1 like this, and I have another function called print matrices. Like it just prints in the form of matrix as we told in the video. Like the problem with Godot is like not with the Godot, with the programming languages is like the matrices are nothing but two-dimensional arrays. So if you just print them as it is, like this, which is technically a matrix, but it ain't looking like we used to represent a matrix. So that's why I just came with the handy dandy function uh, with a print matrix. So it'll be really convenient for us to check um, check the matrices which we are usually familiarized with. So if you just print again, yeah, you just get this. And if you just set the whole value, like if you just want to set values of a row or a matrix, sorry, if you just want to set values of a particular element, like if I want to set I just want to set value of the element which is present at the first row and the first column with the value of 100 and with the value of 100 and the matrix, sorry for that, it's a void matrix with the value of with the row and the column, which is nothing but if you just want to represent a matrix, if you just want to like get the element of the matrix, you have to, this is nothing but what I'm trying to really say is like this is a1, the matrix of 1 1, and this matrix of 1 2, and this matrix of 1 3, and this 2 1 2 2 and 2 3 and 3 3 1 3 2 and 3 3 and so on. So if you just want to represent a particular element, you have to represent like that. So we have three arguments, four arguments, which is one the matrix, two the row, and three the column. So we used to represent like 1 1 and 2 2, but the computer or the programming languages starts with an index of 0. So that's why we just subtracted it by -1. So if you just print matrix or matrix, just a second, we just have a problem and have, oh sorry for that. I'm really sorry for this. Like the first thing it takes matrix and the value of the matrix, and then it just takes the row and column next. So what I did is like gave the row and column first and gave the value of the matrix at last. That's why it just gave an index error. We don't have a 99th element in the array. So that's the problem. So now we got it. The first element of the matrix is 100. So if you just put in the for loop like for I is equal to 0 like this, like if you just want, I'm just saying like you can just use the initialized total value matrix, or if you just have a special condition in your game like you want to change all the values to 0 or 1, you can just use the for loop for I in range um matrix of 0, which is nothing but this matrix, this this row gives Yeah, now we got the matrix of everything. You just change to 100 with the use of two nested for with the use of a nested for loop. What it does is like takes a length of the matrix, which is nothing but the row of the matrix, and takes the column of the matrix. Like if you just have a first element and you have a length of it, like you just have in this case you have this is gonna be the length of 3, so it just iterates up to the 3 and the I value increases after that. Coming back, we just need to next we have an add matrix. If you just want to add matrix, if you just want to add two matrices, it will be it just you can use this function like the resultant matrix and the factor which is if it has an equal row or column which gets into this function and it just get the row of the column. The row is just but nothing but the column length we just have a column which is appended to it so that we just have a total number of column and it returns the column length so that we can just iterate towards it and you can check whether these two are equal. If these two are equal, like for the for the addition you need to check like uh they should be an equal matrix or else they cannot be added. So so if you just look at it like matrix A matrix P equal to initialize total matrix of 3 and it's gonna be 2. So which is going to be an array of matrix from matrix P. So if I want to print the matrix add, it just prints an addition of the matrices. Just a second. It just prints for you, so there is no issues. I forgot to return the function, so there's no need to print that. You can take this off. You can just matrix add. Yeah, you got it. That's pretty much it. Don't consider this. This just you can do matrix. Yeah, this one I used before for debugging purpose. So let me run this again. Ah, you got it. Like the thing which we said it's gonna add. That's thing. So that's pretty much it. Let us move to the multiplication of the matrix. Multiplication of the matrix, like you can't keep on iterating stuff like in an addition. For multiplication of the matrix, you have to like multiply two matrices at a time, not 5 to 6 matrices at a time. So that's why I limited this code to do only two matrices. If you just want to multiply the result, you can just print the result matrix and multiply with that, so it will be really easier to do that. So it just gets the row column of my matrix and the column count of my matrix. Or you can just use, instead of this functions, you can just use this, like instead of getting my row I can just get len of my matrix A, and instead of getting my column count I can just get len of matrix A of 0, which is nothing but the column of the matrix. And matrix and column of 0, which is the column of the matrix. So if you just want to multiply these two, sorry for that. So it came. To test that, we'll just look into this, right? Matrix for the, yeah, we have then we can just put the matrix what we have in this, so we can just test it, which is nothing but a 3 by 3 matrix and it's filled with the value 1 and 2. So 3 by 3 matrix and B is going to be 3 by 3. So we set the matrix and this is going to be 1 1 1 1 1 1 1 1 1, and this is going to be 2 2 2 2 2 2 and 2 and 2 and 2. Yeah, let's calculate it. We get the answer 6. So that's pretty much it of the basic, sorry for that, that's pretty much it for of the basic functions of the matrix which I use this. I'll be covering this a lot in the upcoming videos. Right now I just implemented simple a sim a simple model to explain uh, how we can work with the matrix. So that will be coming soon. Now let's get into the application part. Before that, I want to say that I just took the sprites from Kidney Pixel Map and I just took a background from the Google image. So I'll just put them in the links in the description. So we can just get into it. And the projects will be available in the GitHub description below. So let's let's get this is just a simple scene where I have a plane which is connected to an animation node and which rotates on the start. So that's pretty much it. And it has a frame. You can just click on the frame which moves up to this. And let's get into the code part of this video. So these are the names. These names I got from the internet. Please don't troll me for this. I can't come with a good name for the client. And this about the type, which type they are, and this about, so I couldn't fill more lines that jacks up the user interface, so I just kept it simple, like it's bullet plane, missile plane, and it's both missile and bullet plane. So I just have a variable called current position, and I have these nodes which are stored in an array which is stored in an array. um, these are the nodes which has display groups in it, display, and this also from display. So display, these are all from display, so you can just have a look over it. So then in the ready function we just have a name index, type index, and the frame, which is nothing but the frame refers to the frame in the frame in the sprite which I showed you earlier. The name index and type index is just about these, the names and the type. So if you just look at the matrix, we already initialized them with the 0. So if you just want, we can't just append or pre prepend stuff. So we can just put them, give them equal to, since Godot is a dynamically programmable language. So it's kind of easier to work around with the strings and integers. rather than the static arrays in C and C sharp. So it just added it and appended, increase the name index by 1, and if else if I is equal to 1, which denotes that the row, or I'll just for I denotes the row, and if row is equal to 1, it just has type index plus equal to 1, and you just have a check because the column of the matrix is larger than the type index. So we just have like if it is greater than 3, you can just put them to 0. It just comes to first and it just goes on. So the character matrix will be the type of it, and from here we just gonna compare them with them what type they are. If they are from the type of the bullet, from the first row of the from it's the programmatically way we just say them as a first row. If you just want to say it in the normal notation, it's just the second row. So it just compares with the second row of the matrix and takes about the about of 0 if it's a bullet plane, or about of 2 if it's a missile plane, and about of 1 if it's just a missile plane. And it increases the frame by 1, so that it will be in the first frame, second frame, third frame, fourth frame, and so on up to 10. So a simple for loop to just say that I plus k is equal to value of k like 1, 2, and 3, and so on. And we gotta print the matrix, and we have a change value which is a default argument of 0. So if I is equal to the len of display nodes which we have here, if current node is a label, because we have a label and the animation and the sprite, so that if it's a label, set its text to the current position of the matrix, or if it's not labeled, set its frame to the current position of the matrix. So we just have a save model. I'll just explain it in a few minutes. And these are the buttons, and let's get into the save model then. Save model just does the same, but it just appends them to an element like which we have here, and writes them and calls the write function which creates the file and writes them as a data to the JSON. It gets the length of them elements and appends them to the dictionary and stores them as JSON and closes them. And when button is pressed next, it just increases the position of the one. So if you just have plus position, then you can just, if the position is greater than, like if it is a 10 value matrix, if the position is 11, it just changes to 0, connect, saying that you have to come from the first, and it just calls the change value function again, and it just does the same. It just put the position of 10 in the last. So, and if you just want to load the model, it just creates a file. It just checks if there is no file. It just puts the error no file is found, and you can just save the file, and it just gets the save file. It's nothing but this data. It just gets the data, and we just declare the display nodes again. You can just take that if you want. uh, it just checks if it's an element and convert them to string of string. The problem with the JSON is it just treats the index position as also a string, so that we use the string function of here, and frame it also stores at a string, and I used an integer function there. That's pretty much it. Let's run the particular thing to show you this. So this is the plane, and if I just hit next, we just get the different descriptions of the plane. So I just have this red plane. So if I just hit save model, and if I just give next, and if I just give load model, it just puts out this. And if I just want to save model of this, and if I just want to load this model, and it comes this. That's pretty much it. I hope you guys like this video. Show your feedback. Show your feedback in the comments or in the Discord link, which I'll be sharing in the description. And hope you guys enjoyed this video. Thank you and goodbye.